Hey everyone, so we're going to continue on with problem set 6. So starting off with number 16. So pause the video, work yourself, and we'll go in a second. All right, so what we're going to end up doing is we're going to end up getting the acceleration to be choice C. The way we're going to end up doing this is pretty much doing F net equals ma and using the 50 newtons with the 600 kilogram car. All right, easy enough. Here's the next one. Pause the video, work itself, and we'll go over in a second. All right. Once again, answer is going to be C. So this is a Newton's third law question. The club and the ball always exert equal and opposite forces. However, they will end up feeling different acceleration. So they didn't specify different accelerations, but they will end up experiencing different accelerations because of their difference in masses. All right. Here's question 18. Pause the video, work itself, and we'll go over in a second. All right. So the answer is downward with a constant speed. So because of the fact that we're told that the forces are equal and opposite, we know that it has to be constant speed. So every single one of these choices just gets thrown out. All right. Question 19. Pause the video with yourself. I'm going to go over in a second. All right. Answer here is going to be B, because again, doesn't really matter how much surface material is being covered. All that matters is that the material is the same and the total mass / weight is the same. Therefore, same force. All right. Question 20. Pause video, work itself. I'm going to go over in a second. All right. So what we end up doing, they want us to figure out the deceleration without skidding. So what we're going to end up doing is that's actually just doing a normal force. So FF equals mu Fn. So this will give me the frictional force. And then from there, I can use the F net equals ma equation to get the acceleration. And then we end up getting the answer to be 0.4. Which, oh, yeah. This can also be done by just recognizing that when you do this, you get, let's just call it mu equals, mu times, it's the mass times gravity equals mass times acceleration. The masses drop out, so it just ends up being the coefficient times 10. It's a very easy way of figuring that out. All right, here's the next one. Pause the video yourself and go over a second. All right, again, Newton's third law. So they both exert and experience the same forces going in opposite directions. Like I said, the biggest issue with Newton's third law questions is just recognizing that you're doing a Newton's third law question. All right, here's the next one. Pause the video, work itself, and go over in a second. All right, they want us to figure out which one would have the smallest force applied to it. That means that we're looking for mu to be at its lowest. So the best one is copper, which is choice A. All right. Always remember with these questions, you're looking for one of the extremes, where they're going to be looking for the smallest one or the largest one. All right, here's the next one. Pause the video, work yourself, and go over in a second. All right, we have the FBD. So with this acceleration, I can find the net force. This is something that you want to try to do every time you're told about the acceleration, is to realize that you can find the net force. So do 4 times 10 to get the net force. And then with that net force, we can find that the friction has to be equal to 10. Only one that would give you a net force of 40 here. All right, here's the next one. Pause the video, work itself, and go over it in a second. All right, so this one's a little bit, you have to, best thing to do is draw an FPD. So we're applying a force of 30 newtons to one side of the sled. We have a frictional force going in the other direction, which is going to be equal to mu times the normal force, which happens to be 30. Then we could do F then equals ma. Take this, which will end up getting you 30 minus 6 equals 3a. And we end up getting 8 meters per second squared. All right, last one. Pause the video, work yourself. I'll go over in a second. Okay, so easy enough. The forces are unbalanced, so it's got to accelerate. So moving at constant speed can be thrown out. Uh, this one's bigger, so it's got to be accelerates. Whoop, wrong one. Accelerates to the left. All right, and that's it for these questions. If you have any questions, feel free to let me know. Otherwise, good luck and have a great day.